Hi everybody, welcome to section 5.1. We get to start factoring, so this is going to be a lot of fun. I'm going to keep these videos kind of brief, but hopefully they give you enough of an idea as to what's going on. So here's my first whiteboard. I'll talk through this and then I'll keep erasing and putting up new ones. So here we go. We're talking today about the greatest common factor. Basically, the greatest common factor is the biggest thing you can divide everything in the polynomial by. There, that's pretty clear, isn't it? So here's what we're looking for. We want to use the biggest number that we can divide by. And the key is going to be to use the smallest exponent that we have. And so we'll look at these two examples I have over here, but those are the two things we're really looking for. So here's my first example, 3x squared minus 9x. So I'm really treating this as two separate pieces. The numbers, the 3 and the 9, and then the x's. So 3 and 9, when I look at both of those, I'm trying to ask myself, what are they both divisible by? What's the biggest number I can divide them both by? The answer is going to be 3, right? 3 is divisible by 3, and 9 is divisible by 3. The negative, the minus sign in the middle, honestly doesn't matter. It can be positive or negative, and it'll work just as fine either way. For the x's, since I want my division to come out even, and we'll look at some of that here in just a couple minutes, since I want that division to come out even, I can only use the fewest number of x's that I have. So here I have x squared, here I have just regular x. This is the smallest exponent thing I was talking about. Since an exponent of 1 is smaller than 2, I can only use a single x. For my second example, we have 10x to the fourth minus 15x cubed. Again, I'm trying to decide what divides 10 and 15. The answer is 5. For the exponents, I still, again, want the smaller of the two. 3 is certainly smaller than 4, so what I can divide by here, and we will do this in just a second, is x cubed. And that's kind of where we're going to get started. All right, so here we have a couple of examples of factoring out a greatest common factor. And before I actually jump into these, I start by saying that the greatest common factor should always be the first thing that you look for when we do factoring. So we have many more sections here of factoring that we're going to look at, but every single time you have a problem you need to factor, look to see if there's a greatest common factor. Because if there is, when you pull that out, it's going to make your life easier and it's going to make your answer more correct. So it really works well for a couple of reasons. All right, so let's look at my first example. So the example here is actually the 9x cubed plus 6x. Okay, I wrote out all that I did here, but so that's my example, 9x cubed plus 6x. So when I look at that, again, I'm finding the greatest common factor first. The biggest thing that divides 9 and 6 is 3. The most, or the x's I can use is just 1 because 1 is smaller than 3. So I'm dividing both of them by 3x. And this is really how we do a greatest common factor. We figure out what it is, and then we divide all the pieces by that same thing. So what we get then is that I take my common factor, and it's always going to go in front of the parentheses. And then when we do the division, that's going to go inside the parentheses. And this will be the same thing every time. The common factor goes in front. What you get when you divide goes inside. So 9 divided by 3 is 3. I subtract my exponents. 3 minus 1 is 2. So I get 3x squared plus 6 divided by 3 is 2. And those x's cancel out. And this is factoring. We're basically turning a polynomial back into a multiplication problem. Okay? So it's really the reverse of what we were doing in the last chapter when we were multiplying polynomials together. All right, let's look at my second example. Again, I need a common factor. I mean, you can see it here. I've already done the division with the common factor, but you can see my example here at the top. My common factor is 5xy because I have a lot of stuff happening here. So for the numbers, 10, 5, and 15, those are all divisible by 5. That's the biggest number I can divide by. So hence the 5. For the x's and y's, we take them separately. They really act as two separate parts. And I find the smallest exponent again. So here I have 1x, here I have x to the first, x to the first, x to the second. So I can only use x to the first. Same thing with the y's. I have y to the first, y to the first, y to the second. I can only use y to the first. And that's what I'm going to divide by. So I went ahead and did my division. Notice I took my common factor and I put it in front of the parentheses. Don't lose that common factor. It's part of the answer. It goes in front, and when we divide, 10 divided by 5 is 2. Subtract the exponents, 2 minus 1 is 1. Notice that these y's cancel out, so we just get 2x there. For the second one, 5 divided by 5 is 1, and the x's and y's cancel out. Don't lose that 1. Okay, we did the division. It is 1, so you can't lose it. And then finally, negative 15 divided by 5 is negative 3. The x's go away. For the y's, 2 minus 1 is 1. And there we go. That's how you deal with a common factor. Okay, so now we're going to head toward factoring by grouping, which is still part of section 1. So I have one more greatest common factor problem that we really should look at. Again, ignore what I divided by for just a second. Here's our problem. 4x times x minus 3 plus 3 times x minus 3. This one's a little bit different because now my common factor is a set of parentheses. And that's a little bit weird. You're going to have to kind of get that figured out in your head. But this is all multiplication, so x minus 3 is one piece of this part of the problem. Same thing here. This is multiplication, so the x minus 3 is one piece, just like the x's were in all the other examples we did. Now, since it's the same set of parentheses, okay, this only works because they're both x minus 3, we can call that a common factor. It's in both parts, right? It's over here and it's over here. So I can divide by it just like I would other things. When I do that, notice that the parentheses go away. But also, just like when we were doing the other greatest common factor problems, we're going to take that common factor and we're going to put it in front. So this is a little different. We have another set of parentheses now that's going in front. When we divide, since they go away, we just get 4x and we get 3. And this is going to be key for what comes next with factoring by grouping. Okay, so now we're going to look at factoring by grouping. I have a problem here on the board. I haven't written it out yet, which kind of bothers me. I'd really rather do that. But anyway, here we go. The reason I didn't write it out is because I kind of want you to see the steps here really, really well. So with factoring by grouping, what we're really looking for is something with 4 pieces. So I have an xy, the 5x, the 3y, and the 15. That's 4 pieces. And so with grouping, here's how it works. We're going to make 2 sets of parentheses around the first 2 things and around the second 2 things. And basically, factoring by grouping is going to be doing the greatest common factor a total of 3 times. Okay? So it's a little bit weird. Feel free to watch this example a bunch of times, but it works really, really nice. So here's what I see. Over here on the left, I need a common factor. Okay, so I'm just working with this left-hand side of parentheses. Well, when I look at this, I don't have any numbers that I can divide by, right? I have a 1 essentially hiding here and a 5. So we can call our greatest common factor 1 if you want. But then for the letters, the only letter in common is x. Please note, I have a y here, but I don't have a y there. So the only letter I get to use is x. So I'm going to do the greatest common factor for both of these. I'm going to divide them both by x. Remember, when we do a common factor, it always goes in front. And then when we do the division, x divided by x, those x's go away. We just have the y plus those x's also go away and leave me with a 5. So I've done one of the 3 greatest common factors. I did that first set of parentheses. I pulled that x out. We have x times y plus 5. Let's go do the other set. So we come over here. For the second set of parentheses, what can we divide by? Well, we have a 3 and a 15, which means that my common factor is going to need a 3, because that's the biggest thing I can divide 3 and 15 by. This time, I can't use any letters. Notice I have a y right there in the 3y, but I don't have any letters here in the 15. That means I don't get to use any variables on this one because there aren't y's in all the places. So we're going to divide both parts by 3. Again, I'm going to set that out front, but be careful. We have a plus sign. It's going to come down. We divide by 3. It goes in front of the parentheses. 3 divided by 3 is 1, which just leaves me with the y, plus 15 divided by 3 is 5. Now Notice what that got us. We grouped it and did those two things separately, and this is what we were just kind of looking at in the previous example. We have a matching piece, but it's a set of parentheses, and that's okay. It's actually really nice and pretty straightforward to work with. Our greatest common factor is going to be that set of parentheses. It's that y plus 5. So I'm going to divide both parts by the y plus 5. I divide by that y plus 5, both sides. Again, our common factor goes in front. Don't ever forget that. When you divide by something, we're not really dividing, we're factoring. It's definitely a different thing. It always goes in front. But then it drops out. And what are we left with? X plus 3. And now that's factored. So that's factoring by grouping. Good luck, and hopefully your homework goes well.